So next we have Natalie Chacon Buitrago. I hope I didn't butcher your name. And
No
Natalie,
worries.
okay, great. And you are here. That's good. Okay, so Natalie
Yeah,
is
I'm
coming
here.
to us from the Colorado School of Mines, and she is going to present. I can't move the GoToWebinar thing. She's going to present on deep convolutional neural network as a sedimentary structure classification tool. All right, Natalie, you can go ahead and share your screen, or do I need to give you the permission? Okay, you now have permission to share your screen.
Okay, thank you. Thank you so much. Okay, so hi, my name is Natalie Chacon. I'm a first year master's student at the Colorado School of Mines. And actually, this is not my thesis project, but it's something that I did in my spare time. And I think it has many applications. So what I did was that I collect some pictures. I collect 637 images of different sedimentary structures. So I selected three main categories: cross-lamination, planar lamination, and ripples. And I wanted to classify them using convolutional neural networks. My idea was that in the future you take to the field your phone, and that in the future you will be able to take pictures of the sedimentary structure, and an app in your phone will tell you like this is cross lamination or planar lamination. So that's why I started to play a little bit with this. I want to make a tool that helps to classify sedimentary structures. And this tool is also useful for other applications between sedimentary structures. It can be useful for classifying microfossils, core images, petrographic photos, and rock and mineral hand sample images. So for this, I first collected, as I told you before, 637 images, and I use something that is called transfer learning. So when you use machine learning, you need a lot of data. You need more than 600 images. But in this case, I didn't have that many images. So I use something that is called transfer learning. Transfer learning is when you use a neural network that has already been trained, and you use this trained network with your model. So for this purpose, I use a convolutional neural network that is called MobilNet. MobilNet is a neural network that is frequently used for mobile applications, and it has 88 layers and 4 million parameters. And actually, this convolutional neural network was originally trained with dogs. And it is like really important that I use this type of neural network because it was trained for fine-grained recognition. This means that many recognition tasks are like dogs or cats, but like in geology, at least we need a little bit more of detail because it's not as easy to recognize sandstone at mudstone. We need more fine-grained recognition tools. So the MobilNet convolutional neural network does this task very well. So it doesn't it doesn't classify between dogs and cats. It was trained by classifying different types of dogs. So here there is like an example. And okay, so I will explain a little bit about my methodology, and I will share my code in case someone wants to use it for like a different application or even to continue this project. So, well, first, when you code, you have to import some packages, and these TensorFlow libraries are really good for machine learning and yeah, for machine learning. So to find the 637 images of the three different sedimentary structures that I want to classify, I did different things. First, I collected images from personal galleries, and I asked my friends to give me like some of their images they took in the field. So for instance, this is like a ripple, some ripples that my advisor gave to me. Then I also downloaded images from NASA. So here we have like some cross stratification. And lastly, I also downloaded images from the web. So with this little code, I was able to write some keywords. And thanks to these keywords, all the images on Google that has these keywords will be downloaded in my computer. So I had to process and to see what images were useful for for my project. So I want to make, I have to say again, so I was collecting images for 3 categories: ripples, planar lamination, and cross lamination. And when you do machine learning, you have to divide your data set into a training, a validation, and a test set. So with this code here, what I did was to divide my 637 images into a test set, a training, and a validation set. So this is how it looked. First, I have like these 3 folders in my computer. So 0 stands for cross lamination, 1 for planar lamination, and 2 for ripple. So that means that in these folders, I have like 200 or 200 images of each of these categories. And after I run this code, I had my my data organized into test, train, and validation data sets. And to make sure that that the code ran as I wanted, I printed here. So like I have in the training data set 525 images, in the validation data set to 89 images, and in the test 15 images. And then I start playing with the model. So as I spoke before, as I told you before, I work with MobilNet. So first I had to download MobilNet, and MobilNet here is like a summary. It has 88 layers. So here I have like all the layers. And the key of using transfer learning is that you have to tune your model. That means that you have to see what layers are useful to generate greater accuracy on your predictions. So for this, I have to play a little bit, and I realized that it was the last 6 layers of MobilNet were not useful to train the data, so I didn't use them. And besides, as we have 3 classes, 3 categories that are our cross lamination, planar lamination, and ripples, the output layer has to have 3 units. So I created a dense, a layer, the last layer, the output layer that has 3 units. And well, this is an activation. And with this code here, and then I create the new model. So I use the MobilNet, but I didn't use the first 6, the last 6 layers. And besides, I told to my model like, hey, I need 3 outputs. So my outputs will equal 2 outputs that are the 3 different units that I created. And this is like the summary of that model. And then I start to play with the other layers. So the first thing I did was like, okay, so let's freeze all the layers except the last 40. And here is the summary of that. And finally, I trained the model with those parameters. And okay, I trained the model, and the validation accuracy was 80%. So this validation accuracy, it means how well it's doing on the validation set data set. So the model usually not, the model trains the data in the training data set, and it compares to the validation set to know how well it's doing. So the accuracy in the training set is great, it's like 100%, and on the validation set is 80%. And finally, what's like the normal workflow, the normal machine workflow does is that you have to compare also your data, also your model with the test set. So that was the last thing I did. I ran the model with my test set. And in this case, when all the layers except the last 40 layers of the MobilNet are freeze, the accuracy set is 73%, which is pretty high, and it's good. But then, so I start playing a little bit more, and like if someone wants to play more or like want to use their own images, they can like start playing with many parameters. But what I start doing was to freeze less or more layers. So in this case, I freeze all the layers. I froze all the layers except the last 30. And here the accuracy for the test set was 80%. And I did that again with freezing all the layers except the last 20, and it was 73.3%. So like this link is to the repository I have on GitHub in case someone wants to use the same code. And why I think this is important. Well, this is just an exercise, but I think it has a great importance because it can be a tool in the future to maintain consistency. Because sometimes we go to the field and I can go and say that I saw something, and some other geologists can go and say that, no, I found another type of sedimentary structure. So this type of tools can be helpful to have a consistency of interpretation, and also can help to reduce bias also in interpretation. So yeah, the accuracy was at the end very good. It was 80%, and there are many other things that can be done to have a better accuracy. Thank you so much. Okay, I don't know if if there are questions or.
All right, well, thank you for that.
Okay, yeah, and this is my email.
It looks like Howard has a question. Howard Harper.
All right, he is self-muted, so feel free to unmute yourself.
Okay, I'm unmuted. Natalie, I was just wondering, in your training set, sedimentary structures can have very different views and characteristics depending on what angle you're viewing them from. Do you know if you had like a complete set of what everything looks like from 360 kind of different perspectives in
Okay,
your training set?
Thank you so much for the question. Yeah, so it was difficult because like as I did this in my spare time, I didn't have like time or money to go to the field. But yeah, I tried to make a diverse data set. So as I mentioned at the beginning, I tried to ask to colleagues and friends besides I'm Colombian, so I tried to ask to my friends in Colombia also for pictures. And yeah, I just tried to do something very diverse and very, yeah, and so many of the pictures have like different angles, and they are taken with different like types of light as well, and of different outcrops. But yeah, it would be better if I can collect more images.
Yeah, I know you're kind of done with this project, but work by David Rubin with the USGS. I think he's retired now, but he has it online, and SEPM published a book, Cross-Bedding Bed Forms in Animation, which does give you those different perspectives if somebody wants to continue using this, because I think it's a really good idea to help students understand too how to identify different cross-bedding structures. So good job.
Yeah, sure. Thank you. Can you repeat the name of the book, please? I would love to use it.
It's, if you go to the SEPM bookstore,
Yeah.
I have to go look it up now myself. So,
I can send it as well, Howard.
Okay,
yeah,
thank you.
why don't you do it? It's by Dave Rubin. I think if you just search for cross, you'll show up at the top of the list.
I can send that to Natalie.
Yeah, you can send it to everybody in case somebody wants to, like I said, go on with what she started here.
And then Natalie, how will you be sharing this script? I'm interested to look into it more myself too.
Oh yeah, sure. So this is my email, and I will upload the code. I was doing that today, but I had to work, so I didn't finish that, and the data set to this repository. So if you want, I can share the link, and
yeah, paste that into the chat for everyone.
Yeah, so it will be available tomorrow morning.
All right, that's great. Thank you.
And if you have like ideas or ways of making it better, I'm open, and it would be really nice to know like new perspectives. Thank you.